Next to preservations, the internal cleanliness and dryness of systems, specifically piping and vessels, are the biggest ticket items to affect commissioning and startup, hence will impact the overall project schedule. It is too often the case that construction hand over to commissioning piping systems with debris and foreign material. These are recurring problems from company to company, country to country, indicating a cultural problem in construction with respect to quality. Therefore, the clear advice on this course is beware. Treat all piping systems that are handed over to commissioning with a health warning. Within the commissioning team, the designated mechanical and commissioning engineers will be responsible for tracking and documenting the internal cleanliness and dryness of systems with hydraulic tubing, piping and vessels. In order to flush and clean pipework and vessel internals, it will be necessary to remove parts that would otherwise cause a blockage or obstruction. Temporary spools may need to be inserted. The key, therefore, for the responsible engineer is to know what these items are, when the items were removed and by whom, where any temporary items were installed, where the items were removed from, where the items are stored temporarily, and when the items were reinstated, by whom. All of this will need to be shown on markups of piping isometrics and P&IDs. Items that are commonly removed are filters, strainers and candles. Also valve internals, particularly non-return valves or check valves, orifice plates and sensitive internals from temperature, pressure and instrumented flow valves. Vessel, baffles and temporary internals are also often removed. Items temporarily installed for commissioning are blind flanges, skillets and strainers. Again, these need to be shown on relevant drawings. Cleaning methods commonly used are pneumatic blowing, steam blowing, flushing, chemical cleaning, mechanical cleaning and pipeline pigging. Pneumatic blowing. This is usually air or nitrogen and is introduced from a high energy source to remove loose items from piping systems. The normal procedure is to disconnect piping from vessels, removing all internals that could cause blockage or obstruction. Place a temporary isolation valve at the exhaust, build the internal pressure and release, removing the debris. Note, this is not to be used for cleaning vessels or tube heat exchangers. Important considerations are an air velocity with a minimum of 200 feet per second, around about 65 meters per second. The advantages of pneumatic blowing are principally its cost. The use of air is relatively inexpensive, it is easy to set up and operate, and probably will not require a specialist contractor. In other words, the commissioning team could manage this for themselves. Video 1 shows an air blow at a coal-fired power plant. What piping systems are being blown? What alternative cleaning techniques were considered? What degree of cleanliness did Joel Dingman believe was being achieved? How was this measured? What evidence of cleanliness did you see? What degree of contamination is needed to destroy turbine blades? In summary, be careful not to place too much reliance on subjective techniques. Also, although there may be a relationship, evidence of contamination is not necessarily evidence of cleanliness. In other words, what is recorded coming out of the piping system by way of dust and debris is not necessarily related to what may still remain inside it.
Ever since New Year's, the turbine deck here at the Dry Fork Station has been rumbling. It happens about once an hour, and each time workers get 3 minutes warning.
3 minutes till air blow.
That's the sound that's come 97 times up to this point. The signal, another air blow at Dry Fork Station, is 3 minutes away.
1 minute to air blow, 1 minute.
It lasts only about 20 seconds, but this is the step needed to clean out the pipes before Dry Fork Station can start generating electricity.
So it's to get all that debris out There might even be stuff that's left in there like a bolt or something like that that will get cleaned out of the system.
Doug Rothy is the mechanical performance consulting engineer on site. The last time he oversaw air blows was on Unit 2 of Antelope Valley Station in 1986.
We used to just blow it out the side of the wall and up in the air, but now they're diffuse it into these exhausters to kind of dissipate the energy, and it's safer and there's less debris flying around all over.
Operations Superintendent Joel Dingman says the pipes will get air blown through them 24 hours a day, once an hour, for about 2 weeks.
You don't get to where there's no debris, but you get to where, it's a percentage, I'd say like 90%. You know that you're 90% clean.
If they didn't blow out the pipes on a power plant, debris like welding slag would damage the turbine. That would be a major disaster.
Well, you get a lot of erosion. You might even get, if it's a big piece of debris, you might get significant blade damage or breakage.
Every so often during air blows, a brass target is inserted into the pipes. The target will show damage from debris flying through the pipes. On this day, blow number 100 gets target tested.
You cannot have no more than one impact within 1 square inch on the target.
The air blows will continue for another 12 hours before a target is tested again.
I mean, it didn't penetrate it. You see what I'm saying?
Warning sound, major rush of air, checking the results. An important job in Dry Fork Station commissioning. Air blows finished up successfully on January 9th. Because this method was used instead of steam blows, the plant saved several $1 million.
The disadvantages are, however, its effectiveness, the risk of damage and safety. With regard to effectiveness, this is highly subjective. It is only suitable to remove dust and light debris, and there is a risk of damage to any internals. Safety considerations are to erect barriers and restrict access. Steam blowing is used on steam piping services to remove scale and loose items. The normal procedure is to disconnect pipework from vessels and remove all internals that could cause blockage or obstruction. Ensure the exhaust is sufficiently anchored. Steam blowing is not to be used for cleaning vessels. It requires careful calculation to determine the energy and pressure needed to remove mill scale and debris from the system's internal surfaces. Important considerations are careful calculation of the volume, pressure and duration of each steam blow. Beware of condensation traps. These will cause water hammer and could damage the pipework. Ensure pipework is therefore sufficiently anchored and properly supported. Beware of the impact on other nearby operations and work activities and neighbouring communities. The advantages of steam blowing are principally its effectiveness. It is good at removing mill scale and debris. However, there are disadvantages, and these are also, ironically, its effectiveness with cost, disruption, risk of damage and safety. The effectiveness is subjective. We use targets to check for pockmarks. The cost of steam blowing can be high. It is a lengthy process, and the cost of engaging a specialist contractor is also high. Therefore, allow for this in the budget. There is considerable disruption with steam blowing, and it will have a significant impact on other site activities. Seek to mitigate this by having steam blows at off-peak times, such as lunch breaks or shift changes. There is a risk of damage to pipework and internal items. Take all proper safety precautions, such as erecting barriers and restricting access. Consider using baffles or silencers, especially to minimize impact on neighboring communities. Lag piping for personnel protection. Ensure all personnel in the area use hearing protection. Install structural anchoring at the exhaust, and mitigate risk of damage with relief of steam and debris at the exhaust. Video 1 shows a steam blow at a coal-fired power plant in the US. How effectively was the area barriered off and access to unauthorized personnel restricted? Did you notice anything that would not be acceptable in your normal working environment. List as many as you can in 2 minutes. Video 2 shows a steam blow at the same coal-fired power plant in the US. How effectively would you say the area was barriered off and access to unauthorized personnel restricted? Did you notice anything that would not be acceptable in your normal working environment? List as many as you can in 2 minutes. Video 3 is of a steam blow at a combined cycle power plant in Egypt. Does the support arrangement for the exhaust piping look adequate? Did you notice anything that would not be acceptable in your normal working environment? List as many as you can in 1 minute. Video 4 is of a steam blow at an unnamed plant. What comments can you make about the steam blow in this video? How is it being done? Did it appear to impact other people working at the facility? How effective would you say was this steam blow? Video 5 shows the effect of using silencers. What overall impact do you think silencers have at the facility? Will work activity still be disrupted? What do you think? Will other people be able to work in the area? Fresh water is introduced to remove loose items from piping systems. The normal procedure is to disconnect the pipework from vessels, removing all internals that could cause blockage or obstruction. It is not to be used for cleaning vessels. It is also not to be used in services where water could cause internal corrosion to pipework. Important considerations are to ensure an adequate supply of water and ensure that the required velocity can be delivered of around about 12 feet per second. Ensure the pipework is adequately supported for the weight of water and use a corrosion inhibitor. Vent all high points to prevent pulling a vacuum. Ensure the adequacy of plant drainage systems to cope with the volume of water and the expected contaminants. Fit temporary strainers inside the pipework and agree the removal procedure with operations for a later date. The advantages of water flushing are its effectiveness for the removal of loose debris, but its disadvantages are also its cost. Where large volumes of water are needed, the requirement to install temporary strainers that will need to be removed later by operations, and its effectiveness, because this is very subjective. There are also the risks of corrosion.